Okay, to start off, let's look at these two tables. What I have already gone ahead and done is I've looked at what's been added between each y value. And what I notice is the difference between these two tables is that in the first table, the difference between the numbers, when I subtract 22 minus 17, it equals 5. When I subtract 27 minus 22, it equals 5. The difference between these numbers in the first table is always 5. So this goes up at a constant rate of change. This first table goes up at a constant rate of change. And when I look over at this table here, I see that the difference between the numbers every time is different. It gets larger and larger every time, which means that this is not going up at a constant rate. When an equation goes up at a constant rate of change, that means it's linear, and we can use the equation y equals mx plus b. In this case, our rate is the m. The rate of change is 5, so the equation for this would be y equals 5x plus whatever our y is when x is 0. So we have to go back here. We have to go back to the 0, which means I need to go back 5. So I could look at the point 0.07, which means that the equation for this table is y equals 5x plus 7. All right, when I look at this one, obviously not a constant rate, so we have to look for a different form for what's happening in this equation. So we're just going to leave this as a question mark for right now, and we're going to come back to it after I show you the type of equation we're talking about. So when I get to y equals, or when I get to a table that goes up not at a constant rate, something I might consider is an exponential form for an equation. This looks like this, y equals ab to the x. Or you can also write it as y equals a times b to the x. You guys might want to write this down because I know that some of you have had trouble with forgetting that the exponent only applies to the number that it's right next to. It only applies to the b. So we actually take that number to the exponent and then we multiply it by a. This is where a is our starting value. And b is our multiplier. So in this time, we're not looking for a rate that it's changing by. We're not looking at something that it's adding by. We're looking for something that it's multiplying by every time. So going back to this table, what I can actually do is I know that 100 times x times our multiplier, or actually instead of x, let's use b, since that's our multiplier in this form, y equals ab to the x, equals 150. I know I'm multiplying 100 by something to get 150. So I can divide by 100 to get that b equals 1.5. And I can check my work to make sure that that's true for every single one. So I also know that 150 times the same b should equal 225. So let's divide that out to make sure that we get the same multiplier. So 225 divided by 150 . 1.5 again. So that kind of shows us that our multiplier is 1.5 every single time. We do need to go back and find our zero term, just like we did in our other equation. This is kind of like when we were talking about the contagion thing. We wanted to know what our original number was before the disease was passed on. So, oops. What I'm going to do is I'm going to take 100 and I'm going to divide it by 1.5 to give me 66.6 repeating. So that means that my equation is y equals 66 2/3 times 1.5 to the x power. Okay? All right, so let's look at these graphs. Okay, these graphs are basically, we can think of them as a table as well. So I'm just going to find some points. I'm going to find the intercept, that's 0, 5. I'm going to find the next point on the line, that's 110. So I'm going to put these in my table for x and y. Okay, so I see that my starting value is when x is 0, y is 5. So I'm going to use y equals 5 times, and then I'm going to do the multiplier, which it looks like it's doubling. It's timesing by 2, so 2 to the x power. All right, because basically after every single x, we're going to multiply by 2 that many times. So for example, when I get to the second x, I've multiplied 5 by 2 twice. So I get 20 by doing 5 times 2 squared. When I get to the fifth spot, I'm going to do 5 times 2 to the fifth. When I get to the sixth spot, 5 times 2 to the sixth. I'm just multiplying, I'm doubling that 5 by 2 every single time. Okay? All right. Looking at my next one, I've got a decaying function. I've got something that's going down. Instead of exponential growth, instead of it's getting bigger, it's getting smaller. And so I'm still going to make a table, but my multiplier this time is going to be smaller than 1. So this time our multiplier is bigger than 1, which means it's getting bigger, just like our scale factor in quadratics. When we look at a number or an equation where the line is decreasing in value, that means we're multiplying by a fractional part of a number. We're multiplying by something that is going to make we're multiplying by something that's going to make our number smaller every time. Okay. So I've got 0, 10, and 1, 5. Okay. And maybe we could look even at the next one, 2, 2.5. Okay, so I know I'm still looking for a multiplier. We're not looking at a way to divide this because I can see easily I can divide by 2 to get from one to the next, but I don't want to do that. I want to still look for a multiplier, something to multiply 10 by to get 5. So in case you come to, I don't know if you're able to just kind of, what you need to multiply 10 by in your head, but just so that you have something to fall back on in case you don't know what it's multiplied by, you can set up kind of an equation. I know 10 is multiplied by b, our multiplier, to get 5. So we're going to actually divide 5 by 10, and that's going to give us 0.5. So we can see that our multiplier is 0.5, our starting value is 10, so our equation is y equals 10 times 0.5 to the x. So we've got our b, our multiplier, so add a little note in here. When b is greater than 1, that shows growth. When b is less than 1, that shows decay. All right? So you've got a table right here. I'd like you to go ahead and try to write an equation for the table and then make a quick sketch of the graph. So maybe let's do the graph, sketch the graph first, and then and then do the equation second. Make sure when you do your graph you make a constant scale. So you need to go up to at least 1,000. So maybe you want to count by hundreds and then plot your points in there after you're done. Okay? And then obviously your x's you can just count by ones. All right? Bring that to class when you come next time.